Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. Now, the other factor is the wave itself. So the wavelength is an entire 360-degree movement of an RF wave. This is 1 hertz. And waves have characteristics that are important, like the amplitude of the wave. This is the strength or power of the wave. How strong is it? And the strength or power of the wave attenuates or weakens as it travels through free space and as it passes through materials like walls and doors and floors. The period is the distance between 2 identical points on an RF wave, and a phase is really not a feature of a wave, but it is the characteristic when 2 waves are compared with one another. That is, 2 waves can be in phase or they can be some degree out of phase. When 2 waves are in phase, if they are the same wave, they strengthen the signal received. When 2 waves are 180 degrees out of phase, they can completely cancel the signals, but certainly out of phase waves arriving at a receiver cause a weakening of the signal. Now, how can you have multiple phases of the same signal? Well, you do that because of the RF behaviors we'll talk about later. The reflection that causes the signal to move around within a space so that you get multiple copies of the signal at the receiver at slightly different times, which means they're slightly out of phase or possibly completely out of phase. This is an important thing to consider, and it's one thing that we actually take advantage of in our modern wireless LANs with 802.11n and 802.11ac using what is called MIMO, multiple input, multiple output. We're actually taking advantage of these phase variations and using it to transmit multiple spatial streams.